Hello students, there is your next topic. As you saw in your screen, the topic name is what is system analysis. As the name states, it means the analysis of the system. The system that we are talking about, the system within the organization and businesses, systems of different communications, financial system, etc. A person who analyzes the system is known as system analysis. You heard this term often. The system analysis are employed by organization of businesses to help them improve their system and so become more efficient for businesses and more profitable. Okay, as you go through this block diagram, you can see that there are following steps. These steps are done by the system analysis. That first step is research. In this step, they collect information about the present system works. After that, they analyze it, examining out how the present system works and identifying problem with it. After that, it came design, coming up with a new system that will fix the present system problem. After that, there is production. After that, testing, documentation, implementation, evaluation, which we have also discussed in our previous lectures. So the important topic regarding your exam point of view or for your knowledge also, the topic is black box approach. So what is black box approach? As you can see that a computer program into which user enter information and the system utilize pre-programmed logic to return output to the user. Okay, input. After the input, there is the black box, which you can see on your screen. Input is converted into output, and after that the output comes. In engineering term, a black box is a device, system or object which can be viewed solely in terms of its input, output and transfer characteristics without any knowledge of its internal workings. That is its implementation, which is opaque. Opaque means black. Okay, almost anything might be referred to as a black spot, as a transistor or a human mind. Okay, we take the example. In electronics, a sealed piece of a replacement equipment. In computer programming and software programming, black box testing is used to check that output of a program is as expected given certain input. The term black box is used because the actual program being executed is not examined. In computing in general, a black box program is one where the user cannot see its inner working, or one which has no side effects and the function of which need not to be examined, a routine suitable for reuse. Okay, so these all examples of black box you can note down, and some important concept of neutral networking. It's a very good subject. You can go through it in your extra time, or you can ask about it from your computer science engineering friends that what is neutral networking. Okay, and go through this concept. Or you can say that in finance many people trade with black box program and algorithm designed by programmers. Okay, in physics there is also a black box approach. Here is a mathematical modeling system. You can give this example, go through this example in detail. all these examples are discussed in your classrooms. Go through it, note down it, and attempt the assignment according to it. Then another topic which came is component integration approach. What is component integration approach? As you can see that in many application domains like in automotive systems or production and automation, embedded software has become the driving force on innovation, leading to an increasing demand for software controlled functionality. To meet this increasing demand for software, a component based approach, please note down stand, a component based approach to the construction of software system has become the foundation of state of the art of the software engineering. Okay, in a component based approach, quality assurance is the constructive phase is usually performed in the form of component test and integration of the test. Please go through all these definitions, which is very important. And then the next topic, which is most important for your exam point of view, is system modeling and different theories associated with it. So why there is a need for modeling? The very question arises in the mind of a designer or a system engineer that why model is required. Okay, there are many reasons which might prefer to deal with a suitable for the real thing rather than with the thing itself. Okay, so there is a need for modeling. The main objective of a model is to provide means for analyzing the behavior of a system for the purpose of improving its performance. Or you can say that if a system is not in existence, then a model defines the ideal structure of its future system, indicating the functional relationship among its elements. The reliability of the solution obtained from a model depends upon the validity of the model in representing the real system. So go through this definition and please make note about it. So in your screen you can see that a model of a system. A model is defined as a representation of a system for the purpose of studying the system. Okay, then there are different model process where real system, real conclusion and their formulation and interpretations are discussed. Then we have also discussed in your classes about the types of model. There are various types of model which we have discussed, and some important model which you can see on your screens are mathematical or physical model, static model, dynamic model, deterministic model or stochastic model. Okay, discrete model, continuous model. So there are different model. You can also classify models as like physical and mathematical. In physical there are also static and dynamic, and in mathematical there are static, dynamic. In static you can classify it as numerical and analytical. Same in dynamic you can classify it as analytical and numerical. Okay, you can go through all these definitions of mathematical model, static model, dynamic model, deterministic model, stochastic model, discrete and continuous model. So please note down it. There is also a definition about it. We can discuss the static physical model. So student, the best known example of physical models are the scale model. Like in building, a scale model provides a simple way of determining the exact measurement of the plates covering the roof rather than having to produce drawing of complicated three-dimensional shape. Scientists have used models in which spheres represent atoms and rods or spherical shaped sheets connected the spheres to represent automatic pods. So student, please note down all these topics and we will continue it on the our next lecture. Thank you.